All right, in your packet, go ahead and turn to 8.4. Make sure you're on the reading to learn side for 8.4. There's two sides of notes, and that's the first one. So we're going to come down here and talk about what slope is. We already talked about the steepness of a line when we were looking at that walking rate activity, and we were talking about how the number in front of the x was the rate. Well, the rate and this determines how steep the line is, right? Because when they were walking faster, the line was steeper. Well, that steepness is actually called slope in mathematical terms. So the slope is the steepness of a line. I always like to refer to it as a rise over a run, and we'll get into that a little more. You can also talk about it as a vertical change over a horizontal change, because the steepness of the line, we don't measure it on the slant part. When you go from one point to another on a line, on a graph, you actually have to go left or right, up or down to get to the next point. You have to follow the grids on the graph. So that's why we say it's a vertical change over a horizontal change. It's not a diagonal change. Sometimes and later in algebra, you might see a little triangle with the y and a little triangle with the x, and this just means that there is a change in y over a change in x. So you count the spaces that it takes to get from one y to the next on the graph and from one x to the next on the graph. All right, slope is the same for any 2 points on a line. So let's pretend that this is the line I had. And I have a line here, or I have some points on the line, and they're spaced out apart, right? And from here to here, maybe that was in the grid, that was one space up and one space over. Well, that rise of 1 and that run of 1 means its steepness is just 1. So that person who had a walking rate of 1, their steepness on the slope was 1. Let's say that you wanted to go from this point to this point, and it went up 2 and over 2, 2 and 2. Well, that rise was 2 and the run was 1, so it's still a slope of 1. So it doesn't matter what 2 points on the line you go to, they all will reduce to the same thing and have the same steepness. So the slope of this line was a 1. A line that slopes downward from left to right, so if it's going downward from left to right, or here's my graph and it's going downward, it has a negative slope. A line that goes upward from left to right, so here it is and it's going upward, has a positive slope. And a horizontal line, I like to think of it as skiing. A horizontal line has a 0 slope. The slope of a vertical line, they call it undefined. So I like to think of it in terms of skiing. So horizontal goes this way, vertical goes this way. So this would be going, right, you've got the rope tow, you're going up the hill, but you can still have your skis on, hold on to the rope and go up the hill. You can go down a hill like this. You can still scoot along a flat surface even though it's no fun. And when you watch the Slope Dude video, you'll understand that more. Now this here I like to think of as if I came to something that was completely vertical like that, I could not ski on that. I would plummet to my death, right? So this is not possible. You can't even say it's no slope. That's the same as 0. It's just undefined. It's not possible. For each graph, we're going to draw a line for the given slope. So positive goes this way. Negative goes downward. 0 goes this way, and that's because if you had 2 points and you had a rise over a run, then you would go up none, but then you would go over 1, and that's 0. So it has a 0 slope, okay? That's horizontal. Undefined, what happens here is you can have a rise of 1, but then it goes left or right 0, and you can't do that on the calculator. That's why that's called undefined. Okay? You can't divide by a 0 on the bottom. All right, so let's put this into practice. Flip it over, and let's look at our 8-4 study guide. This is actually on the front. I think it was in backwards. It might be in backwards in your packet. So again, we're going to reiterate that slope is a rise over a run. So it's a vertical change over a horizontal change. Slope is the same for any 2 points on a line, so it doesn't matter where the points are, whether we go up 1 and right 1 or whether we go up 3 and right 3. That's 3 over 3, which again is 1. Now, if you do not have a graph to count, you can find a slope for any 2 points by using this formula here. That's just giving you the 2 y's. So if I had 2 points on there, instead of counting how far up they went, what you're doing is finding the difference between them. And instead of counting how far over it goes, you're just finding the difference of the x's. So you use this if you have 2 points but no picture to count. Okay? So let's say I had 2 points. They were using, let's see, 5-1 and 9-4. And it doesn't really matter which one's the first point and which one's the second point. Whichever one you start with, though, you have to make sure you start with the same x that you from the same point that you started with the y. So if you decide that you're going to start with this first one here, you would do 1 minus the other y is 4. And since you started with the 1 here, you start with the 5, and then you would minus 9, and we would solve this. That's -3. Solve that. That's -4. Anytime you have a double negative, you then turn it into a positive. I want you to notice that they started with the other one, 4 first and the 9 first. So they did 4 minus 1 and 9 minus 5, and they got 3/4 also. So it doesn't matter which one that you start with. Okay? If you wanted to do a rise over a run, using a graph instead of the points. Oh, this one's kind of hard to do because of where they put the points. But I like to always rise up and run. You see how sometimes they put rise and run here? To me, that's a little more confusing because it's under the line than above the line. I tend to make my lines above it. So if I'm here and I'm at 1 and I'm going up to 4, I rose 3. And if I'm right here, it's usually easier to count when they're on actual grids. I'll show you below. If I'm at 5 and I'm going over to 9, I moved 4. So the rise on this one was 3 and the run on this one was 4. Did I get the same thing here? Yes. So you can use 2 points and find the difference in the y's over the difference in the x's to find how steep a line is, or you can count the rise over the run. All right, so we're going to write rise over run. When you go up on a rise, that's positive. When you go down, if it's going downward like this, you would have actually counted for this one, it would have gone up and it would have gone left. So it would have been positive on the top and it would have been negative on the bottom. So if you move right, it's positive. So this line went up and right, so it was positive and positive. This one would have gone up and left, so this one would have been positive and negative, which would have made the slope negative. And if you look, it's going downwards, so it is negative. All right, so let's find rise and run for these. Let's make that a little bit darker. I like to go above, some people go below, it doesn't really matter. The vertical number, whichever way you counted, the vertical one goes on top, the horizontal one goes on the bottom. So if they're not numbered, it counts by ones. This one, to get from here to here, went up 1 and then counted 1, 2, 3, 4 left. Well, because it went left, just like on a number line, that's a -4. So the rise is 1 over -4, but that's just -1/4, okay? So then I've got, if I decide to go down, I will go down 1, which is negative, right 4, which is positive. So this time the negative would be on the top and the positive on the bottom. Doesn't matter if the negative's on the top or the bottom, it's still going to be a negative 1/4. All right, let's count the next one. We're going to go up and right. Count the spaces, 1, 2, 3, up, count 1 right. Rise goes on top, that's 3, run goes on the bottom. If it can be reduced to a whole number, you'll reduce it to a whole number. So all your answers will either be whole numbers or fractions. Let's rise over run on the next one. Find your 2 points, draw your lines to connect them, to make your step. Count up, 1, 2, 3, 4, and then it's going left, 1, 2, 3, 4, 5. So it's a positive 4 for the rise, a negative 5 for the run. And if somebody else wanted to go the other way, they would go down 4, which was negative, but then the 5 would have been positive. It's still a negative 4/5. It doesn't matter whether you have the negative on the top, in the bottom, or smack in the middle. That's a negative fraction, okay? So that's how to find the slope if you have a graph, all right? If you don't have a graph and you have 2 points, so like see here I have 2 points with ordered pairs, but I don't have the picture to count them, then you have to find the difference from one to the other and the difference from here to here. So this is where we use the formula for slope, which would be m being our slope. I should probably put that up there. Mx plus b. Remember, that number there is my slope. The rate is the same as slope. So my slope is y2 minus y1 over x2 minus x1. All right, it does not matter which one is the first and which one is the second. I always just use the one that's listed first to write it first so I don't get confused. So I have to do y minus y, that's 2 minus 4, and then I have to do x minus x, so 2 minus negative 5. You have to be careful with the negatives and the minuses, okay? So change to plus the opposite. Now I'm going to have a negative 2 on the top and a 7 on the bottom. And it wouldn't have mattered if you did it in the other order, because you would have had 4 minus 2 if you went backwards, and then the other one would have been negative 5 minus 2. That would have still been 2 on the top, negative 7 on the bottom. These two are identical. Sometimes people have a hard time with, lining them up or putting them in the right order. It doesn't matter which one. So there's something called a slope slide that some people like to use because it just helps them set up the problem. And what you have to do if you're going to use the slope slide is you have to stack the points, line them up, and then where the commas are, make a little slide. And so what happens is the two numbers slide down on the side they're on. So the 5 and the 2 are on this side, they slide down and you put a minus. The 5 and the 4 slide down and you put a minus between them. You just always have to make sure you put a minus. And then you solve it. 5 minus 2 is 3, 5 minus 4 is 1, 3 over 1 is 3. That's no different than saying 5 minus 2 here, 5 minus 4 here. It's exactly what we did. It just makes sure that it's in the right spot. Because sometimes people will accidentally put the x's on the top and the y's on the bottom. You have to make sure the y's are on the top. So if you want to try the slope slide again, you're going to slide down the negative 4 and the 3 and put a minus between them. You're going to slide down the 7 and the 7 and put a minus between them. This becomes negative 7 over 0, and oop, I cannot have a 0 on the bottom. It is undefined. That means it would be a vertical line. If you're ever not sure, you can always take your calculator and you can test it out. Because if you can get a 0, like if this was 0 over 7, that's 0. If I can get a 0 as an answer, then it's fine. But if I have 7 divided by 0 and it comes out as an error on my calculator, those are the ones that are undefined. Okay?